welcome to the stage, Anil Varanasi.
Hello. Is this thing on? Hello. Welcome to MeterUp 2025. I am super excited. Thank you all for coming. It's great to see how much this has grown since last year to now, and so many great luminaries of our industries and practitioners here. We have many customers here, partners here from schools, warehouses, life sciences labs, retail, hospitality, data centers, everywhere. But one of the things that we really hope you all do is not just learn from what we're doing and get feedback from you on what we should do better, but also talk to each other. We want MeterUp to be the place where people that care about networking convene, and we hope to do more and more of this. We think networking is very important. My excitement for this usually is the fact that we get to hear from each of you about what we can do for the next year, 3 years, 5 years, 10 years. But I wanted to start off by making it very clear that Meter is a networking company. There's not a lot of these networking companies today. And it's really interesting because it's one of the largest markets in all of technology, and it's growing incredibly fast, but there don't seem to be any new networking companies coming in each year. It's probably the most scathing review against the efficient market hypothesis, the fact that, why is this happening? The other thing we do that is core to us is we move packets, and we love moving packets. We think it's really important to do that really well, from how to think about the hardware and other things you'll see today. But we're also at a point where we're comfortable talking about what we've done, and we want to do a lot more of that and bring you guys in, and I'll go through some of what we're going to do for the next few years as well. These days, if you walk around the Meter office, there's sort of this subdued pride about what we're doing and excitement. And folks at Meter have been working really hard. And I'm really proud of the work they've done across hardware, software, operations, models. And I can't wait to hear from all of you what you think based on what you see and what you touch today. This crowd probably knows this intimately, but everything in the world is packets. Regardless of what type of work you do, it is just packets all the way down. And I feel very fortunate that we get to contribute something to that. But that's core to what we do, is we move packets in every way possible. The dependency on networking is growing a lot. And we see this from how fast the markets are growing, but every part of it is just networking is growing a lot. But the number of people coming into networking is actually going down. A lot of you are old like me, and maybe older, like Drew. Today, if you go to any of our great computer science schools and you ask them, hey, what do you think about a switch? They probably think you're talking about a Nintendo Switch. They've never even seen one. And I know, sadly, this happened to me when I was trying to recruit someone from Stanford. This actually happened to me. But the other thing that is interesting is the innovation seems to be sort of stagnant on hardware, on protocols, and what it takes to build something great. And this is what emboldens us more than anything, that we can contribute something to it. One of our theories on why this happened is, in the last 40 years, majority of networking was built through acquisitions. These are sort of seemingly puzzles that are put together from very different puzzles each time. And it's incongruous to us to why that until Meter came along, nobody's built the entire stack. These are some of the largest companies in the world, and some of the greatest networking companies ever built. They're just very different from Meter. The problem is, if you look at somebody like Arista, they're sort of very concentrated on the hyperscalers. And yeah, if you're one of the hyperscalers, it's great. But if you're not, which the rest of us are not, by definition, there's only a couple of them. Palo Alto sort of seems to be running this playbook of the 90s from Cisco, where they just buy a bunch of companies and package the sales and marketing. And Cisco defined a lot of what happened in the industry. Without Cisco, a lot of progress probably wouldn't have happened, and a lot of the internet build-out probably wouldn't have happened at all. But in recent times, they've acquired hundreds of companies, and that's not a number that I'm like exaggerating, it's hundreds of companies. And I shudder to think about is how many hours lawyers build for this, all over. Only if you don't work in technology would you think you can actually combine these different products, these different software platforms, hardware platforms together. It's sort of like mixing oil and water. It doesn't really happen. But what we set out to do is build networking. And we think networking should be built, not bought. And this is doing everything from the ground up. What we have today that's remarkable is across hardware, firmware, operating systems, software, APIs, models. It's a single unified stack. And those of you that have been around networking for a long time, you know how unique that is to do for the entire rack. And there's tremendous amount of benefits for customers because majority of issues in networking happen because of configuration issues and compatibility issues. We've solved that. And this is working at a scale that unless you've been paying attention to us, especially in the last year, you probably don't realize the scale of Meter. These are some of the most demanding networks in the world, everywhere. And every single one of them runs an entire Meter stack. Every single one of them. That's also super unique, as you all know. Usually it's a hodgepodge of things everywhere. And the clip at which we're deploying now soon is going to be in tens of millions of square feet a week. And that's not a scale anybody's ever done before Meter. And this takes a tremendous amount of work from us, but also our partners do a lot for this. Our partners mean a lot to us and our customers. This is everything from what we do in ISPs and deployments and our chips and our manufacturing. But also, it's integral to how we grow. Seeing the channels outpouring support of Meter in the last 9, 12 months has been really interesting to see, and it's been great. So we want to go far, and the way we do it is we do it together. And I'm really excited to announce a partnership with Lumen today, where they're going to combine what they do great on bringing fiber. They're one of the great fiber networks with what we do on the entire networking stack side. Kate Johnson, who's Lumen's CEO, and I will be talking about this later today a bit more. But customers can now purchase what Lumen has and the Meter network all together. And this isn't just like an announcement. It's actually live today, so you guys can all go use it and think about it as great pricing and visibility, all from the ISP to network combined together in a single place. I do want to switch gears a little bit, though. And one of the things we try to do internally is have at least a directional sense about what we're trying to do with urgency as much as possible. And what I wanted to do is give a little bit of a preview of that, of how we think about it internally to all of you. The next 1,000 days are probably going to forge the networking company that will be around for the next decade, 2 decades. I don't know how many people actually understand that. Literally over the next 3-4 years, it'll be set what's the company that is the definitive networking company, which is so important to get right for the coming decade or 2. The work we've done over the past decade has put us in a great position on how to do this. But there's a tremendous amount of work we have to do to actually achieve that. So I actually wanted to give you a preview of where we're going to spend our time, where we're going to spend our resources, where we're going to spend our capital. And there's 3 sort of important philosophies I want to go through. And so that you all understand how we think about what we should be doing. So first, we want to get the basics right. Second, it's how we scale software. And third, really thinking about how do we do this autonomously. So on doing the basics right, our industry is buzzwords, acronyms, et cetera, et cetera. Sometimes I don't even understand. Somebody said something to me yesterday. I thought they were saying something bad to me. It was an acronym. Like, it's remarkable how many acronyms we have. And it's just like this alphabet soup that happens a lot. Alan Kay had this quote 50 years ago while he was working at Xerox PARC, which is people who care about software build their own hardware. And we think this is now true more than ever. And we think it's really important. So one of the first things in doing things right and doing the basics right is we do not believe hardware should be commoditized. Something happened to all of us that we've gotten into this trance where all these legacy companies told us hardware is commoditized, and we just like, yeah, you're right. But of course they're going to say that. Their incentives are totally different. One, they're trying to make hardware for as cheaply as possible. Two, they're trying to sell it for as much as possible. That's their business. That's the margin. And three, with ever so imperceptible differences, they want to sell you new hardware every year. And looking at these model numbers, it's sort of like reading hieroglyphics, and I think you need like a linguistics PhD to discern a bunch of this. By the way, we're not being unkind. These are not names we made up. These are real names of products. Honestly, I don't even know we could do it if we tried to come up with some of this stuff. We just don't have the phenotypes to do these kinds of things. And hardware should be beautiful. It should feel like cathedrals in circuits and materials that make sense. And hardware should last. And you should feel a certain way about hardware when you see it and touch it. We've got some great things to preview for you today, and I'm really excited to hear what you all think on that. Building on that Kay quote, one of the things we believe deeply at Meter is that the people that build the hardware and software should be the ones responsible for it. Even some of the greatest technology companies that build hardware don't mess with real-world operations. It's hard. It's really, really hard. And in an industry where vendors sell you a box and they sort of wash their hands, and then you have to like wrangle this TAC thing. I still don't know what TAC stands for, by the way. It's been 20 years. And it's sort of hard to figure out all these licenses and other things. And sales and things will push you to a certain direction. Not only do we build the hardware and software ourselves, we think we're responsible for it. And that's a very different way of thinking about networking. Very different. At Meter, operations is a product. We actually think about this as a way that we have to learn from how these products are deployed, how they're maintained, and how it can be lasting infrastructure. It's what drives us into what we do differently each year in hardware and software and how it comes together. But it is really hard to do this. Think about the clip at which we're deploying now, and so many of you have deployed networks, how challenging that is to do at scale by being the same company that does the hardware and software. But we think it's a remarkable moat for us, but more than anything, we think our customers and partners benefit from this deeply. And it's something we plan on investing a lot, and you'll hear a lot more about some of the ambitious things we plan on doing over the next year, 5 years, 10 years. But deeply, operations is a product at Meter. A lot of the benefits that come from this is vertical integration is not easy. It's not for the faint of heart in any way. We not only think it's necessary, but we think it can be a huge advantage to do this in a great way. We have some announcements today on the networking side that you all will see. But as a primer, cellular is a product we announced in the last year and a half. It's become a beloved product, which is doing indoor cellular as easy as Wi-Fi. And it's a lot of benefits for our customers and partners, and we're collaborating with all 3 carriers to do this. Connect makes it easy to get ISP pricing and delivery for it. And what's interesting is this is also another product that only Meter does in all of networking. And again, it's confusing to us because how can you have a great network without having a great ISP? And certainly, you can't have a great meter network without it, because we think about this as an entire network, integrating the entire stack throughout. Usually, when networking products are built, when you're building a new product, you have to do it from the ground up every time. Every time, you have to rebuild it over and over again. One of the interesting things we've done is how to think about decoupling this hardware and software so that we can scale it. And Sunil's going to go through this a little bit later on how we think about this architecture and how we've actually built this. But it's a single operating system that goes through the entire stack. And as an example, I can pull out my phone right now and configure thousands of pieces of hardware and networks entirely virtually. And when the hardware is plugged in, the state is just gets down. This gives us many advantages to be able to do things that otherwise aren't possible. Again, it comes from the fact that we want to have software that's great, hardware that's great, but one thing should not hold the other back. And apart from making these things easier, there's some really ambitious things you'll see us do. And it sort of put us on a path that was fait accompli for Meter for a long time. I think we'll finally be able to do what a lot of us wanted for a decade or two. And we probably still don't think and believe that it's possible to do, is to have a single platform that can go from 1 gigabits a second to 1 terabits a second and beyond. Think about this, you're one of our customers that has 1,000 locations in retail, and you're building your own data centers. All of that can be one single platform and a single dashboard to maintain that for the entire thing. Usually that's about 10 to 50 companies that have to come together to be able to do that. And we've spent many years building this mature platform, many, many years. And having this unified platform means we hope you get to benefit most from it. It enables us to listen to what you all are saying and actually make changes. And we try to figure out how we can do faster and faster. But I think one of the beautiful things that's starting to happen in the last year and a half that I expect to have an increase in velocity is because of the investments we've made, how much faster we can go from here. We're also really excited about all the things we have in development in R&D, and I can't wait to show all of you. But one thing in particular that I've been thinking about for the last 15 years, I want to talk about a little bit today, and go a little bit deeper into why we're doing certain things and what you'll see from us over time. As I mentioned, the number of networking engineers is going down in the world, not up, even though the number of networks, data, devices, and applications are growing. Something like 25% of all network engineers are retiring by the end of this decade. And that doesn't even include all the new ones we'll need. This is just replacement rate. If you go look at Bureau of Labor Statistics, after software engineers, network engineers is one of the highest number of jobs. So how do we figure out, as an industry, but also as somebody that deeply cares about building this hardware and software, to help with this? And we want to figure out how to build models from the ground up, and you're going to see some of this today. We think it will be incredibly accretive not to just networking, but all of compute. If networking gets better, compute gets better. And that's been an equation that's true for a long time. And later today, I'm going to talk to Bob Metcalf about that and what he's seen over time. But this is something that's always been true. If networking gets better, compute gets better. So we're building models from the ground up to do the three things that are core to networking, which is designing networks, configuring networks, and managing networks. And you'll see products from us today. Later, Natan's going to go through this. But it is really cool, and I'm really excited to hear about what you all think and what we can do given the position we're in to be able to do it. So we saw this happen actually in autonomous vehicles, where progress seems much faster in the last 5 to 7 years. But one of the main reasons this was possible is if you look at companies like Tesla and Waymo, is they have a couple of ingredients that drive all of this. They control the entire stack. This is from hardware up. Instead of having thousands of suppliers for things, it's a very integrated stack. Second, each piece of hardware sends back enormous amounts of data. And third, you need a lot of compute. Meter is in a very unique position to do this, and probably the only company in networking that can do this, which is we control the entire stack, as we talked about. This data platform that we build, and we're building more, is collecting all of this. And with our partnerships with companies like Microsoft, we have a great partner in building out this massive amounts of compute. You know, I think we have this deep obsession that this thing has to be built from the ground up. We believe that the industry is sort of at a crossroads right now, where not that many people want to be a networking company, not that many companies seem to love networking as much as we do. But we just want to build beautiful products. And beauty for us isn't just pixels or how it looks, but also how it feels, and when you touch it, when you see it. And we think infrastructure can be, and maybe it should be, beautiful all the time. So, if any of us look back in the last 40 years and we said, hey, this is how networking is going to be built, where we're just going to piece a bunch of things together, that's not probably how we would have done it. None of us would make that choice. And we think it's important to figure out how do we course correct at this point. Because we believe internet is one of the greatest forces of good that's ever happened. You put better internet infrastructure in a school, test scores go up. You do that in factories, productivity for factories go up. And it's sort of the kernel that started Meter. And we hope you do this with us for the next decade and beyond. Because one of the simple ideas that we started Meter with is that we all will use internet more than we currently do today. And we don't take this lightly, and we don't take it lightly that you all trust us with critical infrastructure. We understand how important it is that Meter does a good job for all of you to do your work. We just think we're really fortunate to be able to contribute to something like this and help grow one of the greatest inventions possible with networking at its core. Thank you.
Welcome to the stage, Joshua Markle.
Good morning, everyone. I'm Joshua Markle. I'm head of hardware here at Meter. Welcome to MeterUp. Today, I'm going to be talking about everything hardware. People that know me, that work enough around me, have probably heard me say the lines, I'm a hardware guy, I'll build you a sandwich, I'll build you a router, I'll build you a house. It's all just hardware. I'm not going to spend 25 minutes talking about building sandwiches. I think that would be silly. I want you to make the leap and just assume I'm not lying for that one. Building a router, I see a lot of faces that I recognize in here. Hopefully you know my resume, my background, and that I know how to do that. If not, give me another 25 minutes and hopefully you'll be reassured. The last one, build a house, sounds like it's a little facetious because it's so much different than a router and slightly different than a sandwich. But what a lot of people don't realize about me is that I was actually born into a construction family. My father started a company back east in Canada over 50 years ago, building houses. Myself, my 4 brothers, my sister, were all integrated into that company. We all grew up talking shop about building houses. To this day, my family still runs it. They've won a number of awards, high quality houses, great stuff. But that's dinner table talk for us, talking about building houses. I purchased a place in San Francisco back in 2018. I'd like to say it was a new place. Nothing is new in San Francisco. No real estate is new. It was built in the 60s. And my younger brother came to visit me and flew 3,000 miles with his family, comes to my house. Hey, how's it going? The first thing he does is he points. He says, your floor and that wall are off by about an inch over 8 or 9 feet. Grabs a can of chicken noodle soup, places it on the ground and watches it roll down, pick up speed, hit my fireplace. See? Hello, younger brother. How was the flight? Nice to see you. My brother's not a jerk. None of my siblings are jerks. But he does have a critical eye. He's been around the industry as my entire family has. So they notice things like that. And they're very harsh critics for things like that. As you can imagine, they're delightful at housewarming parties, right? That type of critical eye that also exists with our hardware organization. Everyone in our team has an exceptionally critical eye on that. I think there are a lot of people in this industry that don't have such a critical eye. I think a lot of the legacy companies that you hear about have sort of rested on their laurels. That's not something we're ever going to do. And we're always going to be a little bit more ambitious and more bold. Last year I talked about a new network designed from the ground up. We decided what that should be. We started out with the network. We have a diverse set of customers. What would be the perfect network for everyone? We whiteboarded it, iterated over and over, and then we decided what are the pieces that would make up this network. Then we went out and built it. That was our goal, to go out and build these individual devices. We have an incredible luxury and advantage compared to our competitors because we control the whole stack. We know what is always connected to something else. If you have your network and it's a mix match, right? You have maybe a Palo Alto firewall. Maybe you have a Cisco or Catalyst switch and call it Aruba APs. You have essentially a rat's nest of a network, right? They've never tested for this. They've never tried to optimize for this type of setup. They have to build for this setup, obviously, and this network will be fine, but it is going to be the most reliable network that you ever see. If something goes wrong, whose fault is it, right? Now, even if it's not this mix and match, which essentially, if this is your network, this is the first time you've seen it, right? This is a guinea pig network, essentially, where you're the guinea pig. We have a quality engineering team. You'll see them later on today. They test every port to every port, every condition, every corner case, everything. We have that luxury, we have that advantage, right? Even if our competitors don't have this hodgepodge network, they still have to design in the bulk and the bloat to have it. And when I think of hardware has to be beautiful, bulk and bloat are not words I use to describe the things, right? So you can see with us, we wanted to ground up, built, not bought. You see the product family, you see everything. We had 3 key goals for our new product line. Number 1, increase the performance of each individual product. Not 10%, not 20%, 30%. Be more ambitious, be bold. 2x, 3x, 5x, 10x, 20x in some situations. We want every single one of our products to be compared with their peers and be better. My analogy for this is the 1992 USA Dream Team. Every player on that team was better than anyone else in the entire rest of the Olympics. Those are our products. The second thing that was one of our goals, we wanted to make sure that all of these work together, in concert. Not just a series of devices together, put in a rack, but actually intended, knowing that they work together. Designed that way. We wanted a network that was greater than the sum of its parts. The last thing, the third thing, build a brand. I wanted to build a brand that you would recognize. Not just, oh, that's Meter. But build a brand that when you look at it, you know that is the highest performing product out there. You understand that it is the most reliable network. I want people to look at this and know that their network is safe. We did all that. We did all that. I'm not going to keep talking about what's coming, what's going to go. It's here. I'm really excited to announce 9 new products. 1 completely seamless, organic, built from ground up networking stack, fully integrated. 9 new products. Shall we take a look? We have a firewall series. F1, F2, and F3. Our F1 is a 50 gigabit stateful firewall throughput device. I'm not going to rhyme through all of the different spec lines on this. I'd be up here all day. I want you to come down to the Meter Labs. I want you to come by the hardware section. I want you to ask questions. I want you to see the specs. This is a very powerful machine. Very powerful. When I talk about this powerful machine, I want you to imagine a cool autumn day with a leaf blowing down the center of the road. That leaf makes more noise, more sound than this product. This is intentionally built that way. F2, very similar to F1, 20 gigabits of stateful firewall throughput. I want you to picture a smaller leaf blowing down for this one. For the rest of my entire talk, how about we just picture one of those two leaves for every one of our products, okay? F3. F3 is something that I am so proud of. This is a product that does not exist in the market, but is needed in the market. F3 is 2 independent firewalls, 20 gigabits each, independent, connected intelligently inside with a high availability connection. This is the product that nobody makes. This is an industry first. This is a product that all of our customers want. We built this for the customer. This is an outcome for our customer. Next, our switch series, S1, S2, and S3. Your S1, 24 port, M-Gig, all ports M-Gig. PoE++ up to 720 watts. S2, 48 ports, all M-Gig. None of this mixing and matching. You get 1 gig here, M-Gig here, but if you get this other, none of that. Simple for our customer, reliable. And our S3, that's our core switch. 25 gig uplinks, 10 gigs. The backbone of your network. Next, we have our wireless series, our A1, our A2, and our G1. The A1 is a premium Wi-Fi 7 access point, tri-band, custom antennas, custom heat spreader, custom everything. While a lot of our competitors chase more output power to boast on a data sheet, we chase clarity. We take the RF semiconductors, the front-end modules, power amplifiers, LNAs, filters. We partner with the people that literally make that device. They use million-dollar equipment, load poles, network analyzers, to make sure that those devices get every ounce of clarity and performance out of them. They do that for us because of this strong partnership. We have a couple other things designed in. We have an ability in here to have our 5 gigahertz and our 6 gigahertz not even see each other. I'll talk more about that, but that is a circuit that does not exist on any access point in the market. It's something special. More to come on that. The A2, this is our hospitality Wi-Fi 7 access point. This is meant for your hotels. This is meant for your dorm rooms. Every single thing that I talked about with A1 is ported into A2. Additionally, we have 4 LAN ports, 1 with PoE. This is a product that previously has just been accepted that it's not high performing. This is an exceptionally high performing product. This will serve your hotel needs. Last, definitely not least, our G1. This is our 5G gateway. This is fully IP67 rated, which is just a fancy way for me to say it can go outside, it can go underwater up to 1 meter. Please don't put it underwater. Your cell service does not work there. I shouldn't have to say that on a stage. This is 2 ports. It's meant to connect to your F1, your F2, or F3. We have a dedicated port on those products for this product. It's designed to be, if your ISP1 fails, your ISP2 fails, you have a ISP3 here. You're covered. It's one connection. You don't have to power it with a switch. You power it directly from your F1 or your F2, your F3. This has multiple SIM options, global connectivity. So even if you don't have your ISP1 or your ISP2, this is a product that you can rely on for data rates. It'll do over 1 gigabit of throughput. Whatever the cell tower will give you, this will take. This will operate up to 131 degrees Fahrenheit and down to minus 40 degrees Fahrenheit. It's a hot day. Here's your Las Vegas summer SKU and here's your Canadian winter SKU, all one product. This is your new fully integrated meter stack. High performance. Everything here is available early 2026, and we have it in-house today. You see some of it here. You see some of it here. We have our meter labs downstairs. I want you to come touch it. I want you to look at it. I want you to ask questions. I think it's pretty impressive. Next, I want people to understand that these 9 products are not the end game. We're not done, right? We're continuing to build great products with our philosophy. So when you see our 9 new products today, you know that the next 9, 12, 200, et cetera, are all built the same way. Number 1, be intentional. We have a little bit of a joke in the hardware group where we have a critical eye, so we see what compromises go into a design, where we look at somebody's product, not ours, and we think, did you intend for that to look crappy? And we don't mean to throw shade. We don't usually say that publicly. Just realizing that now. But we don't just see the flaws in a design or the size of it, the bulk. We see the compromises that have went through on a design. And I just think if somebody is compromised on something like that, what else have they potentially compromised on? We don't compromise. We set forth our hardware requirements documents, our specs, and our renders, and then we go and build that. We don't deviate. Next, everything matters. Absolutely everything matters. We have the vent holes on our rack mount devices intentionally sized. We have baffles for airflow. We've got our products designed to work at our firmware power dissipation numbers, power consumption numbers. Everything matters, even down to the type of cardboard that we use for our packaging. We could tell you which tree it comes from and which country. Everything matters. By the way, it's a maple tree in Finland. The last thing, take risks. Every single one of our new products, when we kick it off, we want to try and find something new. We want to learn something. We fail. We fail a lot at this, and that's okay. We try it. We don't just become afraid of failure. Failure in manufacturing, failure in production, that's a different failure. We're not ever talking about that. Failure when you're trying to go for stretch goals and enabling that failure is how you make successful products. This blocking circuitry that I talked about for our Wi-Fi 7, we took a risk. It works. It works exceptionally well. Nobody else can do this. We do this. You know what we did with that? We invested that back into our A2, so we get exceptional performance. Every single Wi-Fi device from here on in, we will use that circuitry. We will use that design that we have. When you hit on some of these risks, they pay off big. These are investments. This means that every single time we build hardware, it gets better and better and better. I think that's really powerful. Me talking about this is one thing. Here's a short video. I want you to see it in motion.
takes 1,000 decisions you never see to build a network from the ground up. We don't sell hardware, so we're not focused on minimizing our costs by choosing the cheapest components. Instead, we invest in good materials, state-of-the-art processes, and finding the best partners. Meter developed this high-quality manufacturing toolset so that we can build anything we want. We want to build products that last. It's important to me as an engineer and a designer to find that fine balance of performance and usability and aesthetics. I would love to say that we get it right on the first try, but the reality is that it takes countless hours of engineering. It's normal to encounter challenges or roadblocks where compromising would be the easy way out. But if you compromise, you can't deliver great hardware. That's all we're trying to do. We build what we actually set out to build.
Not gonna lie, I've seen that video probably 10 times in every iteration of it, and I still love it. I love it. You know, you can kind of see our approach in that we're a little bit different from some of the more traditional companies, the older companies. We do things differently. I have a homework assignment for everyone here, okay? You're gonna see a number of switches cycle through. For every switch you ever see for the rest of your life, I want you to pay attention to where the SFP ports are and the RJ45s, okay? RJ45s, always on the left, SFPs, always on the right. Very consistent, always. RJ45s on the left, SFPs there. Does anyone recognize every one of these switches? I want people to put up their hands if they actually do. Yes, thank you, Kay. SFP's on the left, RJ45's on the right. That's never been changed by anyone for the most part. Everyone does it this way because that's what the reference design is. It's such a simple thing to do, but people just add it in and call it a day. There's no value add there. You know, all of the high-speed ports traditionally are on the right-hand side. Yet your switch, you put it on the left-hand side. Little things like that, little attention to details, everything matters, right? Everyone does SFPs that way. Almost. Well, I'm talking about SFPs. I have a second homework assignment for everyone, okay? I want you to pay attention to the SFPs on every product. I want you to look at them. I want you to find them. They're easy to find. They're usually on the left-hand side. I want you to physically touch them. I want you to see that they're always protruded by 2 millimeters, 3 millimeters, 5 millimeters, whatever. Every single time. You can cut your shirt on them. And I get it. That's very easy to do. But it looks ugly. And hardware should be beautiful. Right? These things matter. To do that, what people have been doing, you don't need to really take into account the mechanical stack up. You don't need to work on where the PCB fiduciary points are and how to lock that in to control that. You don't need to have a fixture to place it in the right spot. You don't need a separate fixture to go through your refill process. I get it. It's easy. All of our SFPs are flush or sub-flush. we actually paused our program for a bit so that I could move them 0.2 millimeters back because it mattered that much to us. Everything matters. We intended on designing it a certain way. We want all of our connectors along the same plane. Everything matters. I was asked earlier today, where do you compromise? Surely you have to compromise on something. I compromised by spending $18,400 to do this because it was important, and I compromised on schedule. But we're going to build what we intend to build. I want people to look at things like this and think, Meter does the little things so you can trust that they do the big things. Right? Everything matters. Next up, who thought I potentially were going to talk about audio levels? That little leaf that we were talking about. We have an audio spec, and it's sub 20 dBA at operating conditions for all of our products. It takes a lot of work to do that. We do iterative tests to make sure that we hit this spec for all of our products. We add different custom heat sinking solutions, the way the airflow goes. We've run at least 13 tests on every single one of our product to make sure that we know how to do this. Our products boot up silently. They go through their bootloader, they come into our operating system, and then it elegantly checks a handful of sensors that we've placed throughout the board, then decides, does it need to turn on the fan or not? I can't stand when I spent 8 years at a past life near the switch team, and they just had the fans running at their desk at 100%, 16 RPM. It sounded like a jet engine. I have a disdain for the fan sound. I think the sound level matters. I spoke about, here are our customers, a diverse list of customers. We sell to schools, right? The reason we have it quieter than a library here is because schools oftentimes don't have a networking closet. So this goes in the classroom. I want students to be productive. I don't want any networking equipment to ever be a distraction. We sell to grocery stores. Grocery stores often don't have an IT closet either. It goes in the break room. People work hard. Everyone in this room works hard. When you're on your break, I do not want to be hearing fans. I assume you don't either. Everything matters. The last thing I'm going to talk about is this Wi-Fi blocking circuit. For the longest time, we've had 802.11g and AC, and you've had 2.4 gigahertz, and you've had 5 gigahertz. And those aren't neighbors, those are miles apart. But with 5 gigahertz and 6 gigahertz, these are right on top of each other. You play your TV too loud, and your neighbor's complaining. That's how this is. This is a really difficult problem to solve because a lot of the chipsets that go in here, the Wi-Fi 7 ones, are intended and designed to work at both 5 gigahertz and 6 gigahertz. They're swappable. It's a very elegant design for a chip maker. But it's tricky. It's tricky from a hardware perspective and especially a deployment perspective. So what we do is we essentially build a 6-foot thick wall between the two neighbors, essentially. We have come up with an elegant circuitry so that this one doesn't talk to this one. Your 5 gigahertz and your 6 gigahertz don't talk. There's a lot of data sheet wars that say this is how much your throughput is. But realistically, if you're using Wi-Fi 7, you're always going to have your 5 gigahertz and your 6 gigahertz running at the same time. The number of isolation between your 5 gigahertz and your 6 gigahertz that you need to only have 1 to 3 dB degradation in your receiver sensitivity is over 80 dB. I said a lot of fancy things there, but know that essentially you need this much isolation and you still get your receiver, your ability to listen, your ability to hear, degraded by 1 to 3 dB. 1 to 3 dB doesn't sound like a big number, but remember 3 dB, this is a logarithmic scale, is essentially 50%. Our circuitry gives you 130 dB of isolation. And if it sounds like that's a lot from 80, that's a lot from 80 because it's a logarithmic scale for robust networks. We want the highest performing products. I am proud of every single one of these. These are all our babies, but this is kind of my favorite. I talked about wanting to build a brand for Meter. I want people to look at our products. I want people to physically touch our products. I want people to literally not hear our products. And I want you to think that you know that everything has been carefully designed, that this is a network that you can trust, that it's going to be the highest performing network. I want you to see this, not hear this, touch this, and take comfort in that. I'm Joshua Markle. Welcome to MeterUp. Thank you.
Welcome to the stage, Sunil Varanasi.
Hello. I'm so happy to see everyone here. Thanks for coming. When I was preparing for this session, the team came up with the idea of, can we recreate the Meter onboarding session that I do every month? Can we recreate part of it? And I said, okay, let's do it. And then they said, okay, we don't want to have you slides. Can you whiteboard on an iPad? I said, okay. And they said, can you walk around with the iPad and then write? I said, that's not possible at all. So that's why I have this here today. Every onboarding session, I start with the idea of what matters most is how we deliver our products and how our products solve customer problems. That's what matters most. how we deliver our products, and how our products solve customer problems. We see this every day, constantly, from network engineers, network operators, and partners. They have to make decisions about what vendors, what SKUs, what's pricing, how do you design a network, how do you configure a network, how do you deploy a network. And they have to do it under pressure, time crunch, and last minute. How many of you have deployed a network with ample time? Raise your hands. Exactly. So it takes a lot of decisions constantly to make sure that we're able to deliver the networks. And this is not because of skill set or the intent of the engineers or the operators. It's because of how the products are delivered in a fragmented nature and the complexity of bringing desired state to your deployment state. And that's when we realized that delivering a vertically integrated infrastructure with software that helps bring this complexity or dramatically reduce this complexity, and we can solve customer problems. That's the only way. Vertically integrated infrastructure with software that helps reduce this complexity. And hopefully in the future we can eliminate it with autonomous networks and more automation. So what is desired state networking? When we all try to deploy a network, we have a state in mind. A state of topology, state of connections, cabling. You have state of firewall, state of WAN, state of radios. How do you want to deploy your channels? And if there's anybody in the room that had an experience where your desired state was identical and without any hitch in the deployed state, please raise your hands. So it's a constant struggle between you have a desired state, you want to design this topology in a certain way, and then you want to deploy it a certain way. And then what happens is you have issues. You have to call people and say, did you cable this? Did you cable this? And you have to constantly go back and forth on the phone. You have to constantly go back and forth in debugging. It's a lot of work. And getting networks off the ground is not an easy thing. And again, this happens because of the fragmented nature of multiple vendors, multiple people working on it, multiple pieces of software, multiple dashboards. By bringing everything back into the vertically integrated infrastructure and our dashboard, we can actually solve this. And that is going to be through desired state networking. And I'm going to walk through what desired state networking is. Just in a little bit, I'm going to whiteboard. And hopefully, my handwriting is clear. I don't have any slides, by the way. Okay, so what is, there you go, I made a mistake. What is desired state networking? Desired state networking starts with integrated stack, integrated infrastructure. If you all think that my handwriting is this bad, please don't. This table is shaking a little bit, so. So desired state networking starts with integrated infrastructure. Then it has hardware state. It has software state. It has network state. And it has configuration state. Each of these pieces is extremely important to understand what is the desired state and what do we want from a network. And all of this comes together with real-time data. Real-time data matters a lot because you want to know what's happening on the network live. And this is something where Joshua and even my colleague Natan will talk about how do we get real-time data from hardware and how do we use it. It matters a lot. So if you take the hardware state, it consists of operations, hardware performance, and anything L1, layer 1. And if you take software state, it's going to be firmware and any of the capabilities of the firmware. And in the network state, this is where you have your, I don't know how to spell topology. Topology, connections, and radio settings and what, like, etc. So, and then you have your config state. There's no explanation needed because it's the config state. We store this configuration in the backend. So when you take these elements, what we have done is each of these is stored in our cloud, in our backend. And we know constantly what the state of the whole network is at all times. This is really helpful. One way is when you guys talk about Meter, you can say Meter came up with yet another acronym for networking, DSN. Sounds cool though, right? Better than cryptic ones. So let's talk about how we build this desired state network and what are the components of this network. So let's see. So for the desired state network, you have hardware, and then you have NOS. I'll talk about what NOS is in a bit. Then you have cloud. Then you have applications. These are the components that make up desired state networking from a unit perspective, each unit. From hardware, we have our security appliance and firewall. You know, if anyone has a really good name for this device, please let me know, because we go back and forth between firewall, security appliance, controller. We got to come up with a new term for this. And then we have our switches. Then we have our access points. Then we have our cellular, PDU, and 5G gateway. So like Joshua explained, we really care about every single component in the hardware layer. And we don't store any state on the hardware. We take the state and we store it in NOS, and I'll talk about what NOS is. And each of the hardware is fully cloud managed. Including the PDUs. So when I said, how do we deliver our products? How we deliver our products and how our products solve problems is key for us. A small story about PDUs. PDUs came about because many of our customers were having ISP issues. I think it's very new to you guys, right? ISP issues. So we had to send technicians on site, or they had to use their own people to go into the IT closet or go to the modem and then switch it off and on. Many times they didn't know what a modem was, and that's fine. That's not their job. So we said, how can we solve this? How can we truly solve this where we can actually have the state of the network and we can remotely manage this? And that's how PDUs came about, where you can connect ISP modems to our PDUs and you can reboot them. Small story, but that highlights how we think about networks, how we think about our customers. The same thing with 5G. From day one, we had 5G built into our stack. This helps a lot when your ISPs go down, or even doing installation deployments when ISPs are not ready yet. There's no connectivity to the network. And we can use this connection to see what's happening on the network and have our eyes on it. Now, let's talk about NOS. How do we bring all of the hardware together. When I say it's vertically integrated, what does it even mean? So we have our network operating system. And it's a unified operating system. Before this talk, I was talking to one of my colleagues, and I asked him, what does it mean to you? What does NOS mean to you? He's in the audience, I'm seeing right at him. And he said, it's not about building features for individual platforms. It's about building features for the entire network. So think about it. In a vertically integrated stack, we can have features that are on, let's say, an access point. Do they have to be? They might not have to be. They should be on the firewall. So move it to the firewall for performance. We make those decisions every single day, and our network operating system allows us to do that. It also helps with having a single operating system, which means we can test better. We can test faster. Our feature velocity is much, much, much faster. To bring up a device, it takes us months, not years. And that matters, because customers can use our features, our products, and they can give us feedback, and we can iterate faster. It also helps with hardware replacement. When a hardware fails or you want to upgrade a hardware, super easy. Switch it out, and NOS takes care of it, because it talks to our cloud, and I'll go into our cloud a little bit. So with NOS, we can guarantee compatibility within our stack. When customers upgrade their NOS versions, there is no firmware incompatibility. It's a package of the entire network. So you can go forward or backwards in firmware, and that's absolutely fine. And that's a huge issue. Think about it. If you have to upgrade one platform and that's not compatible with the other platform, or the configuration is mismatched, or any sort of mismatch, you have to deal with that. With Meter, you don't. One firmware, upgrade, downgrade, it's safe. So it helps with better uptime, better compatibility, and it also helps with upgrades and feature velocity. So that's NOS, that's unified operating system. So when I said, how does NOS store the state of the hardware? It uses our cloud. In the cloud, we have something called a virtual layer, or a virtualization layer. We took the hardware and we virtualized it in our backend. What does it mean? Our backend, or our cloud infrastructure, knows exactly how a device is set up, its properties, its hardware, its operating system, everything. So by having the virtualization layer, we're able to make decisions in the cloud before it hits the hardware. That helps quite a bit. You don't want to brick the hardware, right? So when we make changes to configuration and in the cloud, we validate that first using our virtualization layer, and then we push it down to the hardware. And this state consists of multiple things. I'm running out of space here. API, config, database, real-time database, and then you have model training. This is a really important thing that we pushed in the industry. You don't need to SSH into devices. You don't need to know the state on the device by going into the device. The device doesn't even need to exist as a hardware. We can virtually deploy thousands of networks completely from ground up, everything set up, and then you can deploy hardware. And the hardware comes online, gets the state, and knows its state. That makes a huge difference coming back to deployment, coming back to desired state versus deployed state. And this is how we achieve it. And we use the same API, the config database, real-time database, and model training for other applications. For deploying thousands of devices, how many of you had to SSH into something? Raise your hands. Okay. And that is the key where, with the desired state networking, you can solve SSHing into things, going into individual devices, and making changes that don't last, that are not persistent. You want these changes to be persistent, and you want these changes to be on the dashboard so you can see what's happening on your networks. All of this data also helps us, like I said, with model training. And Nitin is going to go over how we do some of these things and what can we achieve because of our infrastructure, the strength of our backend infrastructure. So from the virtualization layer, we have applications. Because of the ability on our backend infrastructure, we're able to build features and applications really quickly. And again, it comes back to how we are delivering the product to our customers and how the product is solving customer problems. The faster we learn from customers, the faster we can build. And from the application side, you have Connect, you have Dashboard, and you have Command. I really ran out of space here. Okay. So Connect, Dashboard, and Command. Those are just examples of what we can do. We can automate a lot of these things. But if you go visit our dashboard, and I hope you get a chance to do that today in the lab, you can see the real-time nature and the state of the network. And then for Command, it allows us to build much better models in real time. And this data doesn't exist anywhere because we collect billions of data points per network per day. And because we own the entire stack, our data is clean. That matters a lot too. And even in the future, when we learn more features and we build more features, we can clean the data quite easily. And this gives us the real strength of how we can deliver a fully integrated infrastructure. So that is what Meter full stack infrastructure is, and that is what desired state networking is. And that's how we bring everything back to how we deliver our products to customers and how our products solve customer problems. Thank you.
to the stage Natan Shalom.
Everyone's standing already. How's MeterUp? Woo! They told me I should do some crowd work. Hi, my name's Nitan. I'm an engineer at Meter. I'm really lucky to be here. I say I'm lucky because I don't come from the networking world really at all. I come from a different world, a world of optimization algorithms, a world of GPUs, a world of living in labs. When I was in this world, we would build these models, we would build these algorithms. And whenever we got the chance to look up from the computer screen, we would talk about how these models, how a technology wave, how this technology wave, how it should come out of the lab and go into people's lives, actually start to change the way they live, the way they work. I can say that only when I got to Meter, and only when I got into networking, did I feel like we could actually start delivering on that. Many in this room, whether you're a network engineer, a partner, an IT manager, you've been there. It's a normal day. Tuesday. You know the big meeting is happening just that morning. You get in, things are going fine, and all of a sudden, one of your colleagues, you know, the one with the suit jacket, collar, maybe his name is James. He runs up to your desk and he says, well, everything broke. The network dropped, call didn't happen. Of course, you're a network engineer, so you start thinking, well, where could the error have been? Maybe the VLAN was misconfigured. Maybe you forgot to have that AP undergo RF optimization. But your colleague, James, he doesn't care. He just doesn't care. The worst part about it, maybe he has a point. A lot of us in this room, you love network engineering. You got into the trade. But how many of us love it when a user finds a configuration issue before we did? How many of us love network engineering because we get to sift through hundreds, sometimes thousands of logs just to find that little issue? Maybe there are a few eccentrics in this room. After all, there's a lot of people here who know what DHCP is. But still, I suspect that the answer is near zero. What we love, why we got into network engineering, is because we love that big, complex network. And we love making that feel invisible. Why we got into network engineering, we like a deployment, whether it's small, whether it's large, that just runs for years, sometimes decades. As we're going to hear from my colleague Fran, far fewer people are actually entering the field of networks. And so the needs, the surface area of our networks, they're getting bigger. And we need some way to meet that demand. All right. Who wants to hear about AI? Okay, well, I asked Anil. He did not let me take away your MeterUp pass, but this is not the conference for you. This isn't the talk. why we're talking about autonomous networks, why we're building it. It's the opposite of plastering all these buzzwords over our marketing materials. We don't say agents. We don't say MCP. We don't say AI ops. I don't even know what that is. Honestly, it's not even really about technology. Just the other week, it was a late night at the office here in San Francisco. I was there with a couple engineers, Sunil and Anil. They were also there. And they brought us over to this desk and kind of huddled over it. And what we were looking at was the original Meter game plan. It was written over a decade ago. It was bullets. If you know Anil and Sunil, they were little figures. Kind of looked like half Microsoft Word, half cave painting. And we went bullet by bullet. The most remarkable part is that everything that was said, it looks almost exactly like how Meter looks today. One platform, everything from ISP procurement down to deployments, hardware design, everything. At the bottom of the page was actually the shortest bullet. It was the simplest. It just said, autonomous networks, comma, fully, period. It's hard for me to even read that not in Sunil's voice. The reason we're talking about autonomous networks, the reason we're building them, it's about why Meter was started. It's about what Meter should be. It's about what networking should be. And ultimately, it's about outcomes for you. Just this past year or two, autonomous networks at Meter, they have just started to really become a reality. We started with Command. It's a product we built over the last year or two. It's the industry's most advanced model-driven product. It's more accurate, it's more precise than any of the other AI products out there, and today it's a core part of the Meter stack. And it's been generally available to all our customers, all our partners since the beginning of the year. Everything we do across the entire Meter platform can be done through Command. You can start by visualizing any piece of information, create breakdowns of what's happening on your network here and now. You can go on to create entire dashboards simply by describing what you want to see. Because Command can control your entire network, even any configuration change, anything that you want to do different on your Meter network, you can do so by just describing it. Many of us have seen and used Command. Many of us love it. And so what I want to emphasize today is two things. First, how is Command possible? And two, what it actually unlocks as a direct step to fully autonomous networks. First, pretty simple. Command's possible because at Meter, networking is built, not bought. We build the entire stack, hardware, firmware, operating system. We make all of that live behind a single data plane that a human, a model, can go into, can read, it can change. Two, the model that we train that underlies Command, it's better than standard off-the-shelf models, specifically in two things. One, it actually understands networking. And two, it's really good at controlling just the Meter platform. That's the way we train it. We figured when we went out and built Command, we could do something really useful for all of you. But what we could also do is build a really clear road to even more complex, even more impactful use cases. So that's exactly what we've been working on over the past year. And I'm really excited that we get to talk about it publicly for the first time today. When an issue happens on a Meter network, one of you, customer, partner, you submit a ticket. That goes to our support team. Our support team has to take a pretty high-level description of what's going wrong. They have to then go into your network, figure out what's the real data on it, where's the problem, what's the root cause. Then they have to get back to you. Even for the most routine, the most basic problem, that takes a human at least 20, 30 minutes to actually do all of that and get back to you. So what we've started to do is models that do that entire process. As you're seeing, that's a ticket that's submitted. The submission of that issue immediately kicks off Command. Now it's Command that goes into your network, does all the information gathering, sometimes 10, sometimes 50 calls against your backend. It's Command that now gets to the root cause as well. Command proposes a resolution. And so if you want to take it, that's just one click away. All of this is available for our network engineers as soon as they come into the issue. That allows them to get back to you faster. It allows them to focus on the conclusions, focus on what matters. And it's been a really a great addition to how we run Meter platforms behind the scenes. When we were going and building Command, every time there was an issue that came in, our process was actually very simple. There was a ticket that hit our back end. Command would go do its thing. And myself, a couple of the other engineers I work with, we would run downstairs and we would go right up to the support engineer who was actually looking at that ticket. And we would say, how did Command do? Inevitably, they would say, well, A was pretty good, B, that was wrong, C could have been phrased differently. And so we would go back to the data, we would retrain Command, and it would get better. That happened again and again and again and again. So we had this loop. Command went and did something on a real network. We had people who really know networking, who graded it, gave it feedback. They would go back into the model, and it just kept getting better. So while Command is useful for support today, again, the point I want to emphasize is how it gets us to autonomous networks. Every issue now is a golden piece of data. We have a real problem that happened on a Meter network. We have what the models thought at each step of the way. We had what the models concluded, what they proposed as the resolution. And we also have what was actually decided still by a network engineer as the real solution to the problem. And we could compare those two. And so what we built, each issue, really takes us one step closer to fully autonomous networks with support. When we saw this happen, when we saw Command and the models that we train get better, we were like, well, great. If we can do this with support, why can't we do this with operations? So we started talking about how that might look, and we started talking internally, also with some people in the field. And the first thing that came up that surprised me was that they questioned, why would you even do that? Why would you go and automate configuration? They said, this is something that's supposed to happen once. And if you actually do it right, that infrastructure runs for years to come. In the classic Meter way, we really push back on that because we know two things. One, it's necessary to be able to route packets really well. That's necessary, but it's not sufficient. It's not sufficient to just route packets if you want to deliver a really great product, service in networking. You have to control the labor. You have to control how things are being plugged in, what's the patching diagram. You have to be able to control all of that. Two, having deployed networks now for a decade, we know that networks are actually the most vulnerable at their inception. We have to take a space, often that starts from literally zero. Then we have to design, we have to go in physically and build infrastructure that we want to run for decades. And so getting the configuration part, getting the operations piece right with command, we were dead set on doing it. And so that's what we went ahead and did. As with all configurations, every network at Meter begins with a conversation.
Okay, yeah, that's right. I remember we talked about it. So it's two physically different properties, 7 buildings total, all connected via fiber. You don't have secondaries. Talk to me about your primary ISP and what the provider is, as well as speed, please.
Yeah, we've got a single monkey brains 1 gig symmetrical circuit. It's at 162.245.21.81. It's a /29. We're interested to procure a Starlink circuit as a backup.
Yeah, that's right. Okay, cool.
So this conversation looks like pretty much every conversation we have with a customer, except that's one piece, and we often have dozens of conversations at a time. We have a customer describing what they want out of their network, their infrastructure, their desired state. What we have to do as humans is then go into the Meter backend. We have to say, oh, well, they wanted this subnet on their VLAN. They wanted their DHCP server this way, their ISPs are this. And we have to keep track of what's being changed, what's being updated, conversation to conversation. Again, sometimes dozens at a time. That's why I'm really happy to announce Command for Operations. Let's look at the same conversation. It's going to be sped up. It's on purpose. It's going to be sped up from how a human says it, but it's going to be slowed down from how our models actually go and configure the network.
You don't have secondaries. Talk to me about your primary ISP and what the provider is, as well as speed, please.
Yeah, we've got a single monkey brains 1 gig symmetrical circuit. It's at 162.245.21.81. It's a /29. We're interested to procure a Starlink circuit as backup.
Yeah, that's right. Okay, cool. So in terms of segmentation across your network, I'm assuming here you've got probably a couple different groups of students, faculty, staff.
Yep.
And then I'm assuming you've got your connected devices, your X, Ys, and Zs. Talk to me about how you're designing your VLANs today.
Yeah, we've got 3 primary subnets that serve students, faculty, and staff. Those are 10.103, 10.104, and 10.105, all /24s. Then we've got a 4th VLAN that houses all of our resources, think servers, printers, security, etc.
Right, okay.
I want to reiterate what you're seeing. That's a conversation, a customer describing their desired state. And we have command taking what was said, taking the transcript, and translating that into what the configuration should be, how you want it. That means setting up your network is now just a series of single clicks, based exactly on what you said. Again, each time we go through a deployment, each time we set up a network, we learn something about networking. The models learn something about networking. The models learn something about the Meter way of doing things. And so each time, the models get better. Soon we'll just have models do the entire deployment process, from conversation all the way to installation. What I want to highlight here is the timeline, how fast things are moving. As a company, we started building Command from scratch a year and a half ago. We went out, we put it in all your guys' hand, we've received great feedback. We then, again, we saw this as a path to fully autonomous networks. So we integrated with actually solving open-ended issues. We then made Command deploy, install networks. And soon, very soon, we're going to have fully autonomous networks. When we start talking about autonomous networks internally, naturally, one of the things that comes up is, what will the network engineer do? In our mind, it's actually very simple. A network engineer will do more. When we say even the term network engineer, the day-to-day of that comes down to configuration, things handed down from other vendors, figuring out how they get stitched together. Frankly, that's not engineering. Engineering is about building something anew. Engineering is about designing something that lasts. And so when we think about autonomous networks and what that will do to the network engineer, we think it's going to put the engineering back into the industry. So as a company, we're going to continue to do the basics of networking right. We're going to scale from 1 gigabit to 1 terabit. And we're going to build networks that do. Not networks that talk, not networks that alert. Networks that do. There's this sense that networking was defined 20, 30 years ago. That now it's about following a playbook that compounds at 2.5% annually. What we have to do is bring the most talented people in technology into networking. A lot of these people work at Meter today. What they want is the new kid on the block. What they want is someone not following a playbook. They want to know, if they come in and do their job right, one of the most fundamental, one of the biggest industries in all of technology that changes. One way to look at that is, our goal is to build the world's best technology. And that just so happens to be in networking. That goes from the hardware we build. You just heard about that from Joshua. It goes from the way we're doing operations. You'll hear about that from Mariana. It goes to the way we're scaling our software stack. You heard about that from Sunil. And it goes to how we're building models here at Meter. And again, we're here to build the best technology. I don't mean that relative to networking. I mean that period. Again, I'm an outsider. I come from a world of research and labs. And we were really sold this pie-in-the-sky vision of what models should look like, how they should go into people's lives. They should turn into products, should turn into things that people use. One of the things that I started to believe a couple years ago, and I believe it even more today, as a society, we're still very much learning how to build great products with models. We saw one time, we had a vehicle, and that went fully autonomous. That's starting to actually change how driving works. At Meter, we think now it's networking's turn. It's time for networking to really undergo this renaissance, this change, make it fully autonomous. Why can't we build a model, a big, beautiful model, from the ground up that just knows networking? If we do that, and it really knows networking well, why can't we speed up the release cycle, testing? Why can't we speed that up 10x, 100x? Why can't we do that? If we build a model which really knows networking, knows our code base, It's hearing what you guys, customers, say. Why can't it make really intelligent recommendations of where our product should go? Why can't we do that? If we have a model that really knows networking, why can't we design entirely new protocols from the ground up? Why can't we do that? Why can't you guys have that? That's why I'm really happy to say, in 2027, Meter will have built, deployed, productionized the first fully autonomous network. And if not, Bob, I will eat my words. Thank you.
Okay. Why are they playing the video again? Let's not tell them to stop.
We will be going on a break. Please return at 11:30 for our fireside chat with Bob Metcalf.